as the last part, we are going to look at what happens when our a or b are negative, and so we are just singling out the negative in and of itself. And so at first we're going to look at when we look at negative f of x. That means again the entire function is multiplied by -1, and that at the end means that all our y's just switch signs. So if they're positive, they become negative, and if they're negative, they become positive. So in our case, all our function values were positive because all our values were above 380 parts per million, and so now they're all becoming negative. So all our points are now below our x-axis, and basically what that means is that our function values are now below 380 parts per million, and so have not gotten as high as before. Now again, we verify that by filling in our table, and we start by making our points, and now we make all our y values the opposite sign of what it has, so in our case negative. And so yes, just like I had first shown it visually, our points are exactly the same way when we first find them algebraically and then would plot them. So our function again is reflected over the x-axis, and therefore all our y values have now the opposite sign. Now let's take a look what happens when we have the negative sign with our x. So we are now investigating what happens when we have f of negative x, and you might already have an idea. Basically our x just becomes negative, and it does in this case actually do exactly what it says it will do. And so we can just write out our points and then just write them out again, but this time the x always has the opposite sign of what it is, because if I take -15 and put yet another negative in front of it, I get -15, which ends up +15. And just like that, every other x value. So 0 of course doesn't change because -0 is still 0, and then our positive values become negative. And now we are going to plot our points. So our -15, 4 is now 15, 4, so on the other side. And now we connect all our points again. And we can see that basically our function is still looking like the same function, but it's reflected over the y-axis. And so all our x values have now the opposite sign. What it also means is that basically if we have a pattern, which we kind of have, right? So the original function goes like in zigzags, slightly higher and higher, increasing, then it's now all reversed. Basically the pattern happens the other way around. So the little zigzag comes first and the bigger one, and everything goes down rather than up. So in summary, one more time of the horizontal and vertical reflection, if the negative is multiplied with the entire function, then the graph gets reflected across the horizontal axis. And if the negative is with the x, as in f of -x, then our graph gets reflected across the vertical axis.